In section 10.4, we are discussing the conic section known as the ellipse. So we've made our way through parabolas and circles, and you can see by my little picture here that the ellipse is formed by taking a plane, flat surface, and then you cut through the cone at an angle. Notice the difference between how the circle is formed, where the plane does not have an angle, and now when we angle the plane, we end up with this oval shape. All right, so it's my goal that you will be able to graph ellipse equations, and you'll also be able to write equations for ellipses if you're given certain information. All right, so let's talk about how these equations are graphed. Here is a ellipse equation. A standard form ellipse equation has to equal 1. You'll notice that my denominators are labeled as a squared and b squared. One thing that's always true, a squared is always the bigger one. So you can see that in this particular case, a squared is 9, b squared, of course, is 4. Ellipse equations always have plus as the operation. And the x squared and y squared, the numerators never change. For ellipses, x squared is always the first numerator, y squared is always the second numerator. What will change from time to time will be these denominators. And what they tell us is they indicate wherever a squared is, the bigger denominator, it indicates which of these axes, either x or y, will be the major axis. All right, so what I'm doing here is an example of the ellipse where x is the major axis. Let's see if we can understand why it's the major axis after we complete the graph. All right, well, here's how we graph this equation. I'm going to take this first denominator, 9, and I'm going to find its square root. Of course, that's 3. And I'm going to put positive and negative 3, square root of 9, on the x-axis. So here's a dot at positive 3. Here's another dot at negative 3. So it's easy to remember the square root of the denominator on the numerator axis. Okay, same thing here. I'm going to do the square root of 4 plus minus 2, and I'm going to plot those two numbers on the y-axis. Positive 2, negative 2. And those 4 points are going to be used to just do a trace, a rough sketch of an oval shape. So do the best you can to make an oval shape. All right, so let me throw some terms out at you. We've already talked about major axis versus minor axis. The reason why x is the major axis is because if you look underneath the oval, inside the oval, the x-axis part is a total of 6 units versus the y-axis part, which is a total of 4 units. So obviously there's a longer x-axis underneath the inside the ellipse than there is y-axis. So this is a good illustration as to why x is the major axis. We have these points. Let's start with these points where we're crossing the major axis. Where we cross the major axis, these points are called vertices. And where we cross the minor axis, these points are called co-vertices. Okay. We've already talked about major axis, minor axis. Let's go ahead and plot the focal points. There are 2, we call them the plural form of focus, is either foci or foci, either one is acceptable. Well, here's how we find the focal points of an ellipse. We're going to use this formula. C squared is a squared minus b squared. Okay, well, let's just identify these variables. C is distance. Distance from center to a focal point. A represents distance. All of these are distances from the center to a vertex. So to look up here, the distance from the center to a vertex is 3 units. So in this particular case, A is 3. B represents the distance from the center. Sorry, this is getting a little messy. To a co-vertex. All right, so we're talking about the distance from here to here. Well, the distance from the center to a co-vertex, in other words, B, in this case, is 2. Okay, so let's see if we can find out how far it is from the center to a focal point. So we're going to do c squared equals a squared, which we could get from either here, it's given to us in the equation, or if you take the letter a, which is the distance from center to vertex, and square it, that's another way of looking at a squared, minus b squared. B squared is 4. Well, c squared is 5. So c is the square root of 5 plus minus. Let's just go ahead and get our calculator, and if we plug the square root of 5 and got the decimal equivalent, it would be somewhere around it. It would be about 2.2. So here's the deal about foci. They always get plotted on the major axis. So I'm going to estimate 2.2 on the x-axis as that red dot. And I'll just erase this one so you're not confused. And then we also have to plot negative 2.2 on the x-axis. So as an ordered pair, since the foci are on the x-axis, we could represent them as plus minus 2.2, comma 0. So those are foci. They need to be plotted whenever the directions tell you to plot foci. And then I'd like for you to show me an ordered pair form where they're located. Okay, so that's the complete graph for this one, number 1. All right, let's try number 2. Well, if you notice, since a squared is always the bigger denominator, notice now the bigger denominator is underneath y squared. Remember, x and y squared never change. They're fixed. But these denominators kind of float, and the location of the larger denominator will indicate which is the major axis. So let's go ahead and plot this. I'm going to do the square root of 16 on the x-axis. That's positive 4 and negative 4. I'm going to do the square root of 25 on the y-axis. Positive 5 and negative 5. I'm going to use those 4 dots to do my best to do a sketch of an oval shape, an ellipse. Okay, well, obviously this case, y is the major axis. The y-axis length inside the oval is longer than the x-axis length. Okay. 2, 4, so 2, 4, 5. So our vertices are 0 plus minus 5. So we could say the distance from the center to a vertex, or A, is 5. And the distance from the center to a co-vertex, or B, is 4. All right, well, where are the foci? Or in other words, what is C? Well, we'll find it by using this formula. So C squared is A squared, which is 25. It's always bigger, minus B squared. C squared is 9. So C we get is, really it's 3, but I just want you to remember that there are 2 focal points. We need to go 3 in a positive direction on the positive y-axis. Remember, foci always goes on the major axis, and we've already seen that y is the major. We need to put another focal point at negative 3. So in ordered pair form, we would write it as 0, positive, and negative 3. And so that's the finished answer for that second example. Okay, well here's an example of an ellipse equation, but it's not in standard form. And before it can be graphed, it needs to be placed in standard form. So just remember, standard form for an ellipse, it needs to be equal to 1. And so to make this equal 1, I'm just going to divide everything by 36. And I get x squared over 9 plus y squared over 4 equals 1. Well, I won't take the time to do this because you probably recognize that. We've already done this one. There's the graph. I just wanted to show you when you run into equations that are not in standard form, they do not equal 1, you're just going to need to divide by whatever this number on the right side of the equation is. And make sure you divide all the way across. And then just reduce, and then you're ready to graph, just like we did on the previous two examples. Okay, now when you get to this first set of problems, 1 through 8, they're going to give you 2 points. One of these points will be a vertex, and the other will be a co-vertex. And we're going to use that information in order to come up with the equation for the ellipse. Remember, vertices are, those are points where we're crossing the major axis. They should be points that are further away from the origin than co-vertices. All right? A squared is always bigger than b squared. So let's take a look. If we just did a little rough sketch, and we have this ellipse that goes through the point 0, -6. I'll just put -6 over here. And the center is at the origin. That means that it's got to go through +6 on this side. Okay? I'm sorry, I got that turned around. Back up. Let's try that again. -6. Boy. +6, -6. All right, now we're good. And then we got 3 and -3. Okay, so these are on the x-axis. This point's on the x-axis, but I just concluded that if there's one point on one side of the origin where the ellipse crosses, then there must be another matching point on the other side. Everything's centered around the origin. But you can see that the distance from 0, 0 to 0, 6 is farther than it is from 0, 3. That's pretty obvious. So 0, -6 is considered a vertex. So we can label that with the letter A. A is 6. That means this other point, 3, 0, that's not as far away, it represents a co-vertex. And we always identify co-vertices with the variable b. So in this case, b is 3. It's 3 units. All right, y is the major axis. And so I need to place a squared underneath y squared because the bigger denominator needs to go under the major axis. Okay, so a squared is 36, b squared is 9, and that's my answer for number 1. Number 2, again, you don't have to do these rough sketches, but it might help. Let's just say here's 4, and so therefore we have to have -4, and then 1, and therefore there must be -1. Well, the distance from 0 to 4 obviously is greater than it is from 0 to 1. So x is the major axis. A, in this case, is 4. That's the distance from 0 to a vertex. B is 1. That's the distance from 0 to a covertex. And we just need to write our equation to show that x is the major axis. So x squared, think of it this way, x squared gets the bigger denominator, which is always a squared. So x squared over 16 plus y squared over 1. You don't have to write denominator 1, but if you want to, it's okay. And that's my answer for this second example. All right, here's another one, and we'll finish this up with this one. Maybe we won't do the rough sketch this time, but hopefully you can see that the distance from 0 to this point is greater than the distance from 0 to this point. So we're going to consider this to be a vertex. So that distance is 8. Covertex, that distance is 4. And the y-axis distance is bigger than the x-axis distance. If we were to graph this, we would see a total of 16 units between the vertices on the y-axis, but only 8 units between the covertices on the x. So in this case, y is the major axis, and so it gets the bigger denominator. Okay, it gets a squared, and 8 squared is 64, 4 squared is 16. And so that's my answer to this example. All right, when you get to this block of problems, the way they give you the information is a little different. Instead of saying you have vertices and covertices, they're going to give you height and width. So let's just start off with a little picture here. Everything is centered at the origin. If this ellipse that I'm about to draw has a total height of 4 units and it's centered at the origin, then that means that 2 units have to be above the origin and 2 units have to be below, the total of 4 units. If it's got a total width of 10, that means we're going to have 5 units on the right of the origin and 5 units on the left. Okay? Well, you can see that x is the major axis here. So I'm just going to write in general, this is the equation form that we're going to use. A squared being the bigger denominator, x being the major axis, so x squared is going to get the bigger denominator. You can think of it that way. All right, the distance from 0 to a vertex, or in other words 5, or A, is 5. The distance from 0 to a covertex, or B, is 2. So you can see pretty obviously that a squared is going to be 25, and b squared is going to be 4. Okay, let's try this one. This time we're told that the height is 13, so that means half of it, 6.5, should be above the origin, and half of it should be below. It's got a total width of 5, so half of it should be to the right of the origin, and the other half should be to the left. Okay, well obviously it's longer from 0 to this point, so A, which is the longer distance, is 6.5. B, representing covertices, is 2.5. Y is the major axis, so when I write my equation form, show it like this. Since y is major, it gets the larger denominator, which is always a squared, meaning b squared is going to go underneath the minor axis, in this case x. Okay, so grab your calculator, and you need to do 6.5 squared, which is 42.25. A squared is 42.25. And b squared, 2.5 squared, is 6.25. And that is my answer for example number 5. Okay, we're almost done. This last block of problems, 28 through 32, here are the instructions given in the book. We're writing an equation given the foci of an ellipse and the covertices of the ellipse. Okay? Well, foci being on the y-axis tells me that y is the major axis. There's two ways of looking at this. Foci is always on the major axis. In this case, they're on the y. Covertices are always on the minor axis. So in this case, that's the x. Okay, so showing y as the major axis, showing y as the major axis, I'm going to use this equation. It's just going to be my job to find out what is a squared and what is b squared. Well, I gave you a formula to use, that same formula that we used to find foci earlier. Well, now we're going to use it to find a squared. All right, it's 4 units from the center of the ellipse to the focal point, so that means c is 4, so c squared is 16. It's 2 units from the center to a covertex, so b is 2. That means b squared is 4. So what I don't know is a squared. I'm not told what the vertices are, so I'm going to have to solve for a squared using my formula here. If you just add 4 to both sides, you get a squared is 20. Okay, so now all I have to do is replace these denominators, a squared and b squared, with actual numbers, and I'll have my answer. A squared is 20, and b squared is 4. Okay, let's try this one. The location of the foci, they're on the x-axis. So x is the major axis. Another way of looking at it, the covertices are always on the minor axis. Well, these points are on the y-axis. So y must be the minor axis. So here's the basic equation form for an ellipse where x is the major axis. X squared has the bigger denominator, a squared. We just have to find out what a squared is. It's 7 units from the center to a focal point, so c is 7. It's 6 units from the center to a covertex, so b is 6. We just don't know what a is, so we can't figure out what a squared is. So let's use our formula. C squared equals a squared minus b squared. 7 squared is 49. We're solving for a squared. B squared is 36. If you add 36 to both sides, you get a squared is 85. So we're ready to finish our answer. A squared is 85. B squared is 36. That's our equation. Okay, I think I've given you plenty of examples. That's the assignment that we will be checking for section 10.4. And do your best on it and contact me if you have any questions.